So what if the entire universe is built from just one single shape? Today, we're diving into a wild theory that says our whole reality, from the tiniest particles to the biggest galaxies, all comes from the geometry of one simple form.
You know, for over a century, this question has been right at the heart of physics. We've gotten really good at figuring out the rules the universe plays by, but we have no deep explanation for why these specific rules were chosen in the first place. It's the ultimate mystery, isn't it?
Okay, so to really get what's at stake here, we need to talk about our best description of reality, the Standard Model of Particle Physics. It's an incredible theory. It describes all the fundamental particles and forces we know of. But, and this is a big but, it's got a huge hole in it. And here's the problem. The Standard Model needs more than 19 of these things called free parameters. Basically, these are numbers the theory can't predict. Physicists have to go out, measure them in experiments, and then just plug them in by hand. Think of it like this. Our best theory of reality has over 19 dials that are just set to these incredibly specific, very weird-looking numbers. And if you were to just nudge any one of them, even a tiny bit, the universe as we know it, stars, planets, you and me, it just couldn't exist. It's like this perfectly tuned instrument, but we have no clue who or what did the tuning. So the question is, why these numbers?
Well, what if the answer isn't some super complex equation, but something way more elegant? A single geometric shape. This is the radical idea behind a new framework called unified dynamics, and it just might solve the mystery of those 19 dials.
This framework, developed by independent researcher Benjamin Walker Mays, puts forward a pretty stunning idea. The fundamental rules of the universe aren't arbitrary at all. They're actually the inevitable, unavoidable consequence of pure geometry. And this is the shape, the tetrahedron, or more technically, the complete graph on 4 points, K4. Unified dynamics says that this simple, minimal 3D structure is the fundamental building block. It's literally the source code for our entire universe. It's the ultimate Lego brick of reality. This quote really just nails the core claim of the theory. The numbers aren't random. They are baked right into the structure of this shape. The universe has to be the way it is because this geometric form couldn't have produced any other set of rules. And here's where it gets really, really bold. Remember the Standard Model with its 19 plus dials? Unified dynamics aims to derive all of those fundamental constants from first principles with 0 dials. No knobs, no adjustable numbers, nothing. It's an all or nothing gamble. And if it's right, it's one of the biggest leaps in physics since Einstein.
So, you're probably asking, how on earth can one simple shape possibly hold all the complexity of the Standard Model? Well, let's zoom in and see how this whole thing is built. Okay, this is what's so cool about it. It's so simple. The theory maps the structure of the forces in the Standard Model directly onto the parts of the tetrahedron. You literally just count its pieces. The 4 faces, that's the strong force. The 6 edges, that's the weak force. And the 4 vertices, or points, that's electromagnetism. It's a direct one-to-one mapping. Just beautiful.
Okay, mapping the force structures is one thing. That's pretty neat. But how strong are they? That's where those pesky fundamental constants come in. To get the actual numbers, you need a kind of universal key, a Rosetta Stone that's hidden inside the geometry itself. And that key is something called the Regé deficit angle. It's basically a way to measure how curved a surface is at a specific point. Because the tetrahedron is so perfectly symmetrical, the curvature at each of its 4 corners is exactly the same, and it has a value that is totally unique. No other simple 3D shape has it. And that value is exactly pi, right? Pi. This is the big aha moment for the whole framework. This number, pi, which comes purely from the shape's geometry, becomes the universal constant for calculating the strength of every single fundamental force. It's the key that unlocks everything, and it's been hiding in plain sight this whole time. So the theory has a structure, and it has a key, but does the key actually fit the lock? Can it predict the numbers we actually measure in our labs? All right, let's look at the predictions.
This is where your jaw should probably hit the floor. On the left, you've got the predictions from unified dynamics, calculated using nothing but the tetrahedron's geometry. And on the right, our absolute best, most precise experimental measurements. I mean, just look at how close they are. The strong coupling constant is off by just about 1%. The weak mixing angle, which the theory predicts is exactly 3 divided by 13, is accurate to 0.19%. It's just stunning. And this isn't just a couple of lucky shots in the dark. In total, this framework has spit out 16 different predictions that are all within 1.5% of what we've actually measured. And the only thing you need to plug in is the mass of the electron, just to set the energy scale. Everything else, it just flows from the shape. And it doesn't stop there. It gives a structural reason from the shape's symmetries for why there are exactly 3 generations of matter, something the standard model just takes for granted. It derives this really weird, mysterious relationship between particle masses called the Coity ratio, which has puzzled physicists for decades. It even predicts things about the early universe that match data from the Planck satellite almost perfectly. Now, for any new idea in science, being elegant and accurate isn't enough. It has to be testable. It has to make predictions that we can go out and check and potentially prove wrong. This is where unified dynamics really earns its stripes. And that's what makes this a real scientific theory and not just some cool mathematical idea. It makes hard, specific predictions about what we should find in the universe and, just as importantly, what we shouldn't find. It puts its neck on the line. Here are some of its make-or-break tests. If scientists ever discover a 4th family of particles, the theory's done for. Its architecture demands exactly 3. If that weak mixing angle is ever measured to be significantly different from that hard prediction of 3 over 13, the model breaks. And, of course, if we ever prove the universe doesn't have exactly 3 spatial dimensions, the whole framework just collapses. These are real, testable predictions. So that leaves us with this final, massive question. Are we just looking at a series of mind-bogglingly beautiful coincidences? Or has an independent researcher working from nothing but pure geometry actually stumbled upon the fundamental blueprint of reality itself? The numbers are there, the predictions can be tested, and honestly, it makes you wonder if the universe is a lot simpler and a lot more beautiful than we ever imagined.